So I wanted to do 3 quick warm-ups just to, before you go ahead with today's lesson, just to practice drawing some of our Lewis structures. So if I haven't mentioned it, you should note that I have left the answer key to yesterday's worksheet on Lewis structures on the middle lab bench in our classroom. So you'll be able to verify your answers and see if you're on the right track with all of this. All right, so let's go. Without further ado, I'm going to give you this one to try. So CH4. So I want you to pause the video, and I would like for you to attempt to draw the Lewis structure for CH4. And when you're ready, resume the video. All right, so the first thing that I typically do when I'm drawing a Lewis structure is I go ahead and I count the total number of electrons that are available in the structure. So for CH4, I know that my carbon atom has 4 valence electrons that are available, and I know that each hydrogen has 1 valence electron, but I have 4 hydrogens. So when I add all of that up, I'm looking at 8 electrons in total to work with. So the next thing that I do is I go ahead and I place the atom with the greatest bonding capacity in the center. Now, you might be saying, well, hydrogen needs 1 electron more, and carbon needs 4 more. So carbon has the highest bonding capacity. I'm going to put carbon in the middle. And then in this case, I know that carbon has 4 valence electrons, so it's going to be able to make 4 bonds. I'm going to put those hydrogens all around. And now I'm going to start to draw a bonded pair between each set of atoms. And a bonded pair, remember, we represent by a stick, and that stick indicates the presence of 2 electrons. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So now the last thing I want to do is I want to verify that all of my atoms are going to be stable in this configuration. So I know hydrogen, even though it only has 2 electrons, right? Those are these ones in this bond. It's okay with that because hydrogen only has, remember, hydrogen is in a case where it has only 1 valence electron, so it's happy by gaining just 1 other one. So each of these hydrogens are nice and stable. So now when I go ahead and I count my carbon, I know I have 2 electrons here, 2 electrons here, 2 electrons here, and 2 electrons here. So my carbon is also happy. Hopefully you did okay with that. Let's move on to the next example. So the next example that I would like to do is C2H6. So take a minute to try and figure out how you're going to be able to put this molecule together. Pause the video, give it a try, and resume the video when you're ready. All right, so I'm going to do my electron count here. I know that for carbon, I have 2 carbon atoms times 4 electrons, valence electrons available. My hydrogens, I have 6 of them. Each has 1 valence electron. So that will give me 8 plus 6, which will give me 14 electrons to work with. All right, so now you may have recognized that there's no way for a single atom in this molecule to be the central atom. So I can't have, for instance, I can't have carbon in the middle and then have all of the other atoms around it because, of course, carbon has 4 valence electrons, so it doesn't want to make any more than 4 bonds. So that leaves me with no other choice but to say, well, why don't I bond 1 carbon to the other carbon? And so now what I'm going to do is I'm going to say, all right, I'm going to distribute the hydrogens evenly between the 2 carbons and create a single bond. And let me see how that works out when I do my electron count. So I know that my hydrogens are good to go because they don't all have the extra electron that they need. Oops, I forgot a bond here. There we go. But let's do my carbon count. So carbon has 2, 4, 6, 8. So this carbon is happy. Now this carbon, which I'm going to call carbon number 2, has 2, 4, 6, 8 electrons. So it's also happy. So this is the structure for C2H6. Hopefully you did okay with that. Let's try another example. So for our final example today, I want to try something that just to see how you do with it. So I'm going to give you nope, let's back that up a bit. I'm going to give you CH4O and see how you do with that. All right, so let's do our electron count. So my carbons are contributing, I have one carbon, each contributing 4 valence electrons. I've got 4 hydrogens, each contributing a single valence electron. And I've got oxygen, and I've got one of them contributing 6 valence electrons. So when I do my electron count, I've got 4 plus 4, 8, plus 6. So again, I've got 14 electrons to work with. Okay, so we're kind of in the same situation as we were in with the previous example, in that I can't, I'm going to put carbon in the middle, not oxygen, because carbon needs 4 more electrons, and oxygen only needs 2. So that makes carbon the atom with the greatest bonding capacity in this situation. Now I know that I can't put all 5 atoms, the 4 hydrogens and the 1 oxygen, around that single carbon. That's simply not going to work. So, and I can't put another hydrogen off of a hydrogen. So for instance, let's say I went ahead and did this, hydrogen, and then I'm going to bond a hydrogen to it. Now you can see quite clearly that hydrogen has more electrons than it can handle. It's got this pair here and this pair here. So it's not going to be stable with 4 electrons bonding. So that's not going to work. So I know that the oxygen somehow is going to have to, let me switch pen colors here, be bonded to the carbon. And then I know that carbon can handle 2 more hydrogens, 1, 2, 3, out of the 4. So I'm left with 1 other hydrogen and no place to put it except for my oxygen. And so let's just do a quick electron count. I've got 14 electrons to work with. I've used up 2, 4, 6, 8, 10. So I've got 4 more to go, and I'm going to put the 4 on this oxygen that quite clearly does not have a full octet. And by adding another 2 lone pairs, that gives it the full octet that it's looking for in order to be stable. So this is the configuration for CH4O. There it is. Hopefully you did okay with that. And you're ready to proceed with today's lesson. Now, if you're struggling with Lewis dot structures, please come and see me for some extra practice or some extra help, and I'll be happy to assist you.